Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very nice, a super duper nice exponential equation. And this is probably gonna cause a lot of controversy, I know, because, well, you'll see in a little bit why. Okay, but think about this problem. We have 1 to the power z equals I. So some people claim that any power of 1 is 1, right? 1 raised to any power is 1. So it can never be I. But do you think so? Let's find out. So we have this interesting equation, and here's what I'm going to do. Obviously, one thing that you can do, but it's not going to work, is natural logging both sides. Let's do it. ln 1 to the z equals ln I, and then bring the z to the front. Z ln 1 equals ln I. And then ln 1 is 0, so z times 0 is 0, 0 equals ln I. What did you obtain? Nothing, right? Except for a false statement. Obviously, I'm oversimplifying things here because ln 1 is not always 0. What do I mean by that? Well, in the real world, ln 1 is 0 because that's the x-intercept. If you think about the graph of ln x, right? It kind of looks like this, right? And we have an x-intercept. And that's where x is equal to 1. Great, okay. And obviously x cannot be 0 or negative in the real world, but it can never be 0 in the complex world either. But it can be negative. It can be complex. It can be imaginary. It can be anything pretty much. So ln I is kind of well defined in the complex world, but it's not well defined, sort of, because it is multi-valued. What do I mean by that? I'll explain that in a little bit, but notice that this approach doesn't really get us anywhere. So let's start fresh. 1 to the z equals I. What am I going to do? I'm going to complexify 1. In other words, I'm going to write it in polar form using Euler's number. Thanks to Euler, we have a lot of good things that he worked on, and one of them is E, which is very helpful. So we can go ahead and do this. 1 in the complex world, as you know, appears on the real axis. This is the real and this is the imaginary. So you can kind of think of complex numbers as two-dimensional or vectors or whatever points. And 1 appears on the real line. So it makes an angle of 0 radians or 2 pi radians or 4 pi radians or any multiple of 2 pi radians with the x-axis or the real axis. So what is that supposed to mean? It means that I can write any complex number as r e to the I theta, where theta being the angle or the argument, r being the modulus or the distance from 0. Of course, for 1, it's 1, right? The absolute value of 1 is 1. So now we can write 1 as e to the power I times theta, right? R is 1, so I don't need to worry about it. But theta is a multiple of 2 pi, so I can write it as I times 2 pi n. Some people are going to write it as e to the power 2 pi ni. No big deal, same idea. Probably better to write the I at the end. Okay, cool. Now this is just 1, and we need to raise it to the power z. This is where some of the problems come in, okay? And then we have I on the right hand side. I is going to be on the imaginary axis because it's imaginary, right? Surprise. And it can be written as e to the power I times pi over 2, but guess what? We can also add multiples of 2 pi because, again, we're allowed to rotate, right? That's what I meant by multiple values or multi-valued nature of these things. But what about ln I? We didn't even do ln, right? Well, we're going to do it to bring these down, but don't worry, it's going to be nice and clear. So what do? Multiply the exponents or just natural log both sides, and you're going to get the following. 2 pi ni z, like niz, equals I times pi over 2 plus 2 pi k. We may have to simplify things a little bit here and there. You know, we don't want to overcomplicate it. But first, notice that I cancels out. Another thing that's not directly visible is the pi, because we can pull out a pi and write this as 1/2 plus 2k, and then set it equal to 2 pi and z. Now I is gone, and we can go ahead and simplify the pi as well, or cancel it out, and we're getting closer to z. So once we clear everything. Now from here, we can basically divide both sides by 2n, right? So z is going to be wait, didn't pi cancel out? Okay, I forgot to cancel out the other one. Sorry, pi. And from here, z is just going to be 1/2 plus 2k divided by 2m. But let's simplify this a little bit. It doesn't look that nice. Well, we can kind of make a common denominator, 4k plus 1. And then the 2n, it will be multiplied by 2. And that's going to give us 4n. Interesting. Now, I forgot to say, but hopefully you guessed, k and n are integers. Make sense? Okay. Cool. Now, this is the z value. What's that supposed to mean? Well, it just says that, okay, if I raise 1 to the power 4k plus 1, and I forgot to say, but we're going to look at the result from Wolfram Alpha at the end, which I think will be pretty surprising. But wait a minute. Let's simplify this a little bit, right? This looks too complicated, too complex. Let's set k equal to 0, but don't set n equal to 0. That's very problematic. Don't do it because you'll have a problem. But if you set k equal to 0, you're going to be okay. So it's going to be 1 to the power of 1 over 4n. And it's an integer, so we're kind of talking about 1 over 4 times an integer. And again, and you can, for simplicity's sake, you can just assume n equals 1, for now at least. And this will turn into 1 to the power 1/4. Wait a minute. In the complex word, this has a meaning, doesn't it? It just means the 4th root of 1. Wait, it means the 4th roots of 1. There's 4 of them. And guess what? One of them is I. What's the other one? The other one is negative I. And another one is 1, of course, itself. And then negative 1 works as well. So think about it. Like, you take any one of these numbers and raise it to the 4th power, you get 1. Because I squared is negative 1. Square that again, you'll get a positive 1. Get the idea? Okay, cool. So which one do we take? It's up to you. But I want to get I. So I'll go with I. Well, wait a minute. There are 4 values. So do you think 1 to the power z equals I will be satisfied by 1/4 because it's only one of them? So it's part of the solution. What do you think? Well, I think this will be a solution, but don't let this confuse you or mislead you because I want to hear what you think. But this is the main idea. What happens if I replace k with 1 and n with 1 at the same time? Then I get something like 1 to the power 5 over 4, which can be written as 1 to the power 5 to the power 1 over 4. Now here's the thing. 1 has 4 4th roots, but it only has 1/5 power. You see, the thing with powers, the powers are more powerful, right? Sort of. And I don't know, maybe it's the other way around. But 1 to the 5th is 1, so this turns into 1 to the power 1/4, which also gives us 1. I mean I, sort of, right? What happens if you switch the order and do the 4th root first? Then from here, again, what do you want to get, right? Well, I want to get 1, but I could also get I, so this could be equal to I to the 5th, which is I. So kind of we're getting there, but what do you think? Let me know, because this brings us to the end of this video. But thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.